Steps for balancing a chemical equation. When number of atoms are same on the left hand side and right hand side of the chemical equation, then the equation is said to be a balanced equation. A chemical equation can be balanced in a few steps. Let us take one equation and try to balance it. SO2 plus H2S gives S plus H2O. Step 1. Rewrite the given equation as such. SO2 plus H2S gives S plus H2O. Step 2. Compare the number of atoms of each element on both sides of the equation. Step 3. Choose the reactant or product having maximum numbers of atoms. In the given equation, select SO2 and the element oxygen in it. There are 2 oxygen atoms on left hand side and only 1 on right hand side. Equalize the number of oxygen atoms in order to balance them. In order to equalize the number of oxygen atoms, we just cannot add an oxygen atom to H2O on the right hand side, as this will change the formula of water. That is, H2O to hydrogen peroxide, H2O2. We can only change the coefficient of the complete molecule. Thus, the reaction can be written as SO2 plus H2S gives S plus 2H2O. Step 4. Equalize the number of hydrogen atoms as in step 3. This gives SO2 plus 2H2S gives S plus 2H2O. Step 5. Now balance sulfur atoms, the only element left to be balanced. This gives SO2 plus 2H2S gives 3S plus 2H2O. Step 6. Count the number of atoms of each element in equation given in step 5 on left hand side and right hand side. As the number of atoms on left hand side and right hand side is same, this equation is a balanced chemical equation. Types of changes. We come across various types of changes in our daily life. Some are temporary, physical, and some permanent, chemical. For example, ice changes to water, physical change. Milk is set into curd, chemical change. ripening of fruit, chemical change. Steam is condensed, physical change. Our respiration, chemical change. Physical changes. A physical change is a type of change in which the form of matter is altered, but one substance is not transformed into another. For example, ice changes to water, water into vapors. Vapors are condensed back to water and then ice. In this whole process, the form of matter, that is water, keeps changing from solid to liquid and to gas, but the chemical constituent remains H2O for all of them. Let us do one experiment and find out if it is a physical change. Gently heat camphor in a china dish. Keep an inverted funnel plugged with cotton over the dish before we start heating. We see vapors of camphor rising up. This is sublimation, that is, solid changing directly into vapor state. Remove the burner and let the funnel cool down. We observe small white crystals of camphor deposited on the inside of the stem of funnel. This is a physical change as the form of matter. That is, solid state of camphor is altered to its vapor state and then back to solid, but its chemical composition remains the same. Chemical changes. A chemical change is a chemical reaction which is accompanied by change in the nature, appearance, and identity of the reactants, and sometimes evolution of gas. For example, fermentation, photosynthesis, digestion of food. Let us do one experiment and find out if it is a chemical change. Take 5 milliliters solution of potassium chromate and add few drops of barium sulfate solution. Yellow color of the solution gradually fades away with the formation of yellow colored precipitate. This is a chemical change, as this is accompanied by change in appearance of the reactants forming new substances. Bright yellow solution of potassium chromate reacts with barium sulfate to give yellow precipitate of barium chromate and solution of potassium sulfate. Every chemical change results in a chemical reaction, which is represented by a chemical equation. The substances that undergo change are called reactants, and substances formed at the end are the products of the reaction. Chemical equation. Let us observe a chemical change. Copper powder is heated in a china dish. Copper molecules combine with oxygen in air and form black-colored copper oxide. This is a detailed description of the chemical reaction, which is lengthy. If we abbreviate it in a single line, it can be represented as copper plus oxygen gives copper oxide. This simple form of representation of chemical reaction in words is known as word equation. Or we can make it more concise by using chemical formulae as Cu plus O2 gives CuO. Representation of a chemical reaction using symbols of the elements to indicate chemical formulae is a chemical equation. Writing a chemical equation. The substances that undergo change are called reactants, and substances formed at the end are the products of the reaction. The reactants are always represented on the left-hand side, LHS, while the products are shown on the right-hand side, RHS of the equation. Reactants and products are separated by an arrow pointing towards the products and the tail towards the reactants, thus representing the direction of the reaction. If the number of reactants and products is more than 1, they are written with a plus sign in between them. The conditions of a reaction, that is, temperature, pressure, catalyst, etc., are mentioned on or below the arrow between the reactants and products. The physical states of the reactants and products should be mentioned in the chemical equation to make it more informative. The gaseous, liquid, and solid states are symbolized as G, L, and S respectively. For example, edible oil L plus hydrogen G, fats S. The chemical equation should be balanced, that is, the number of atoms should be same on left-hand side and right-hand side of the chemical equation. Balancing the chemical equation. According to the law of conservation of mass, the total mass of the reactants remains equal to the total mass of the products during a chemical reaction. In other words, the number of atoms of each element remains same before and after a chemical reaction. Types of chemical reactions. Part 1. Combination reactions, endothermic reactions, exothermic reactions, decomposition reactions, displacement reactions, double displacement reactions, redox reactions, combination reactions. When two or more substances, that is, elements or compounds, combine to form a single product, then the reaction is known as combination reaction. Here, iron combines with sulfur to give a molecule of iron sulfide. In this case, tricalcium aluminate, that is, cement, combines with water to give concrete. Endothermic reactions. The reactions where reactants require or absorb heat to convert into products are known as endothermic reactions. When potassium nitrate dissolves in water, there is absorption of heat during the reaction, and the temperature of solution falls. Exothermic reactions. The reactions which are accompanied by the evolution of heat are known as exothermic reactions. Here, solid sodium hydroxide dissolves in water to form its aqueous solution, evolving heat. This is an exothermic reaction. In this case, plaster of Paris on addition of water converts to gypsum with the evolution of little amount of heat. POP, that is, plaster of Paris, is used in surgical bandages, decoration of roofs, casting, making statues, crayon manufacturing, etc. Decomposition reactions. The reactions in which a compound is broken down into simpler components are known as decomposition reactions. Decomposition can be brought about by heat, light, or acids. Sugar molecule decomposes to carbon and water on heating. Calcium carbonate decomposes to calcium oxide and carbon dioxide on heating at 1273 Kelvin. As the above decomposition reactions are carried out by heating, these are also known as thermal decomposition reactions. Hydrochloric acid decomposes calcium sulfide into calcium chloride and hydrogen sulfide. Photo-decomposition reactions. The pale yellow silver bromide undergoes decomposition and turns grey when exposed to sunlight. A similar reaction is given by silver chloride also. This property of silver chloride and silver bromide is used in black and white photography during the process of developing. Potassium ferrocyanide, that is K4FeCN6, also undergoes decomposition in presence of sunlight. Hence, it is stored in dark-colored bottles. Types of chemical reactions. Part 2. Displacement reactions. When a more reactive element replaces a less reactive element from its compound, then the reaction is termed as displacement reaction. In the given reaction, more reactive iron displaces less reactive copper from its compound, copper sulfate, forming its own compound, that is, ferrous sulfate. Let us understand displacement reaction with the help of an experiment. Dip a zinc strip into a clear blue-colored copper sulfate solution in a beaker. After some time, the zinc strip gets diminished. The blue color of the solution fades away and copper particles are deposited at the bottom of the solution in the beaker. Thus, we infer that more reactive zinc has displaced less reactive copper from its compound. Double displacement reactions. Reactions in which exchange of ions between both the reacting molecules takes place, forming a precipitate, are called double displacement reaction. Here we see that positive ion of first reactant, that is, silver, combines with negative ion of second reactant, that is, chloride giving silver chloride, and negative ion of first reactant combines with positive ion of second reactant. In this case, copper ion combines with iodide ion and chloride ion reacts with potassium ion. Thus, positive and negative ions of both the reactants are exchanged to form the product molecules. Oxidation and reduction. Oxidation reactions. Chemical reactions involving addition of oxygen to the reactants resulting in the formation of corresponding oxide as a product or removal of hydrogen are known as oxidation reactions. Here we see that oxygen is added to aluminium giving its oxide, that is, alumina. In this case, copper adds oxygen to give copper oxide. As both these reactions show addition of oxygen for the formation of products, these are known as oxidation reactions. When sodium is reacted with ethyl alcohol, sodium ethoxide and hydrogen gas is formed. Here, hydrogen is removed from ethyl alcohol. Hence, this is oxidation reaction. Reduction reactions. Chemical reactions involving addition of hydrogen to the reactants or removal of oxygen from the reactants are known as reduction reactions. In this reaction, hydrogen is added to carbon, forming methane. In this case, an atom of oxygen in the form of nascent oxygen is removed from the molecule of ozone. Both these reactions are examples of reduction reactions, as in first case, hydrogen is added, and in second case, oxygen is removed. Nascent oxygen is freshly liberated oxygen in atomic form, which is highly reactive. In a chemical equation, nascent oxygen is shown in square brackets. Types of chemical reactions. Part 3. Redox reactions. When oxidation and reduction take place simultaneously in a given chemical reaction, it is known as a redox reaction. In the first equation, oxygen is removed from barium sulfate, reducing it to barium sulfide, and the removed oxygen adds to carbon, oxidizing it to carbon monoxide. In the second equation, oxygen is removed from sulfur dioxide, reducing it to elemental sulfur, and the removed oxygen adds to hydrogen, oxidizing it to water. As in both these cases, oxidation and reduction reactions are taking place simultaneously. These are known as redox reactions. Neutralization reactions. A chemical reaction in which an acid, an alkali, or base react together to form salt and water is called neutralization reaction. Edible oils are compounds, that is, esters of alcohols, and organic acids, that is, carboxylic acids. These acids in oil are neutralized by alkaline soap or detergents, and this reaction is indicated by turmeric, that is, yellow color present in food, which turns red in color. Corrosion and rancidity. Corrosion. Corrosion can be defined as the slow process of decay or destruction of a metal due to its chemical reaction with air, moisture, or acids. A reddish-brown colored layer of iron oxide formed on the surface of iron objects is known as rust, which is the effect of corrosion. Its molecular formula is Fe2O3.H2O. Corrosion causes damage to buildings, bridges, automobiles, ships, and other articles mainly made of iron. Corrosion can be prevented by coating the exposed surface, by applying paint or anti-rust solution, or by the process of galvanizing or electroplating with other metals. Steel is an alloy, that is, mixture of nickel, chromium, carbon, and iron. As it is not pure iron, it does not get rusted. Rancidity. Rancidity is a chemical process in which edible oils or fats get oxidized over a period of time. Oils or fats acquire a foul odor, taste, or froth due to oxidation, or when allowed to stand for a long time. Storage of food in airtight containers or addition of antioxidants prevents oxidation and thus rancidity.